Alright, the last thing in chapter 2 that we're going to talk about are absolute value equations. Now, they're actually easier than absolute value inequalities, and so if you're okay with the absolute value of inequalities, then this should be a piece of cake. The only reason why I did inequalities first is because we had just been doing inequalities for a while, so it made more sense to do them first. But 2.6 has two parts, inequalities and equations. So here's equations. So basically, absolute value of x equals 5. So this is one of the simplest absolute value equations we run into. Basically what this means, well, you can almost think through what the answer's got to be. What's the answer got to be? Well, there's two ways for x to equal 5, or absolute value of x equals 5. The obvious way is that x could equal 5. Alright, oops, that's supposed to be at 5. Let me undo that. So that's the obvious. If absolute value of x equals 5, one way that can happen is that x is actually exactly 5. Okay? But the other way is that, well, wait a second, what is the absolute value of negative 5? The absolute value of negative 5, if I plug a negative 5 in here, these bars mean, hey, make stuff positive. Negative 5 becomes positive 5. X equals negative 5 is also a solution. So the central idea about absolute value equations is the vast majority of the time you get two solutions. One corresponding when the inside of the absolute value is positive. One corresponding to when the inside of the absolute value is negative. Okay? And even when there's something more complicated between the absolute value bars, so this is only slightly more complicated, I'm putting x plus 4, doesn't matter. You still are going to get two answers. One for when the inside of the absolute value equals the positive version, so 5, and then one for when it equals the negative version, x plus 4 equals negative 5. Okay, so you get potentially two answers. Most of the time you get two answers. Okay, and notice it kind of corresponds to the inequalities that what we've been doing. You had to make a negative 5, you had to make a positive 5. Okay, same deal. Okay, except this is a little bit easier. You don't have to worry about the ands or the ors. You just solve both things, and that's that. So here you would get what happens when you solve it. You subtract 4 from both sides, so you get x equals 1, and you subtract 4 from both sides, and you get x equals negative 9. So you get two answers. So you get, in fact, let me plot those. You don't have to do this, but some of you might appreciate, oops, that's the wrong thing. Copy, paste. Okay, so you get two answers here. One at negative 9, one at 1. By the way, well, I don't want to get too much far into it, but notice they're equidistant from the guys. These are 10 units apart from each other, just like this guy was 10 units apart. There's all sorts of different things you can notice when you graph stuff. Although that's going a little bit off topic. You guys don't need to be able to do that. All you got to do is basically solve them. So one way it's easier is that you don't really have to do what I'm doing here in graphing the answers. You just need to get x equals 1, boom. X equals negative 9, boom. And that's horrible. But yeah, circle your answers. Do a better job than what I just did. Alright. So I'm just going to knock out a couple more examples, and then a couple of special cases that are real quick as long as you know what to do. And that'll be that. So what happens here? One important thing to remember is that you don't just make everything positive on the inside. You only... Okay, that is not, I don't just go plus plus. That's not how it works. All right, you do the exact same kind of process. You make two equations. One for the positive 5, and I don't know why I used 5 twice in a row, but I did. One for the positive 5, so negative 2x minus 1 equals 5, and then one for the negative 5. Okay, so negative 2x minus 1 equals negative 5. So you make one for the positive, one for the negative. Okay? So then you just go ahead and solve these. Both of these are Algebra 1 equations. Now, both of these two. So you take one equation and make it two that are simpler. All right, you can't just directly solve an absolute value equation, just like you can't directly solve an absolute value inequality. You got to turn it into two things without absolute values. That's just the rules. All right. So add 1 to both sides, we get negative 2x is negative 4. So x equals 2. Okay. Another thing that makes these easier than the inequalities, you don't have to worry about, I divided both sides by negative 2. Great, that's fine. You don't have to worry about switching the direction of the inequality in it, because there is no inequality. All right, similarly over here, we get negative 2x equals 6. So x equals negative 3. And so lo and behold, check it out, we get two answers. Okay, let's see if I can circle these better. Negative 3 and then positive 2. I'm not even going to risk it. Positive 2. So there you go. One last thing, and I alluded to this a little bit on the, I had an example kind of like this on the inequality video I put up yesterday. But you can't do this switch into two equations, go from one equation to two equations. You cannot do that. You cannot not do that unless the absolute value is by itself in the equation. So for instance, that's not the case here. You have to do a couple things first before you can do the switch. And what do you got to do? Well, oops, you got to accidentally move the equation. All right, what you have to do is, well, just regular algebra moves. So what you first have to do is realize that I messed up and that wasn't going to work out very, very appropriately. So I changed the problem just now. And so there you go. Here's some moving magic. I wanted to change it to a negative 8. It wasn't going to work out right with the 14 that was just there. So like I was saying, you just do regular algebra moves. You just get the absolute value by itself. Well, there's two things over here by the absolute value. There's a 4 and then there's a minus 2 times blah, blah, blah. So you have to cancel out both of them. How you do that? Well, it's just the same thing as if it was anything else. You got to subtract the 4's first. And so you get negative 2 x plus 3 equals, wow, that's negative 12. And then divide both sides by negative 2, and you get x plus 3 in absolute value, oops, equals 6. Okay, and if we'd done the problem that I had initially tried to do, what would have happened, you might, if you go back and look, I would have ended up with a negative number here. And actually, this is a next problem. We're going to talk about how, oops, that's weird. That's a different scenario. And I didn't want to do that quite yet. So that's why I switched it. It would have been x plus 3 in absolute value equals a negative number. But then now it's exactly like the ones we were just doing. So x plus 3 equals 6. Or x plus 3 could also potentially equal negative 6. Because if you absolute value the x plus 3, it becomes positive. So it could have been that this was negative 6 initially, and then it gets absolute valued. Okay, apparently that's going to be a word, or two words. It becomes positive. And so here we get x equals 3, or x could equal negative 9. So you get your two solutions. All right, two special cases, and, well, I kind of alluded to it just a second ago. X plus 4 equals negative 5, x plus 4 equals 0. So here, notice all the problems over here when we get the absolute value by itself, or maybe it starts by itself, positive, 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 6. Everything's positive. So guess what? It's different if it's negative or 0. Well, what do? Well, absolute value equals a negative number. Wait a second, it makes no sense. Absolute value has to be at least 0. It can be 0 or positive. That's what absolute values can be. That's the rule. So this is impossible. All right, so that's the deal. How about this one? Okay, as soon as you realize, as soon as you get something like this, you can just stop. So this is nice. If your absolute value equals negative, you're done. You know there's no solution because it's impossible. So, an equation that could not possibly be true. Now here, absolute value equals 0. So you could switch it into 2, but think about it. That'd be silly. If you switch it into 2, it'd be positive 0, negative 0, and last I checked, that's not, I mean, that's the same thing. It's not really, doesn't make any sense. 0 is neither positive nor negative. So really what's up is if you get something like this, it's the easiest type. Well, okay, I guess maybe here on the left is easiest because you know you can just stop right away. But here, you just say x plus 4 equals 0. Okay, so if your absolute value equals 0, then you just drop the absolute values. And so it's x equals negative 4. So this is one of, these are two exceptions to having two solutions. The vast majority of the time, well, I shouldn't say that. Basically what it boils down to is if this number over here is positive, you're going to have two answers. If this over here is negative, you're going to have none. And if it's 0, you're going to have 1. So there you go. That is how you handle the end of the chapter, actually. So it's 2.6. The equations part of 2.6. And so the classwork tomorrow will involve all that. And there you go.